it is time to partake in the sorrow of y equals negative x squared. We know from earlier the table of input-output pairs will look like this. We have the familiar 0, 1, 4, 9 on either side, but this time they're all negative. I'm going to switch to tropical color markers to try to lighten the mood here. First, I'm going to graph y equals x squared on top. So here we have y equals x squared, our regular happy little parabola. Now, let's graph our points. -3, -9, -2, -4, -1, -1, 0, 0, 1, -1, 2, -4, and 3, -9. And there it is, Mr. Frowny Parabola. So, what happens to the graph when we times it by -1? Every single positive value flips over and becomes a negative value. So it is a reflection of our parabola over the x-axis. Let's take a look at these two quadratic functions and look at the parabola they graph to. But first, let's lightly draw in the original parent function, y equals x squared. So there's y equals x squared, roughly drawn. Let's see what happens when we get y equals 2x squared. We already calculated the values, but -2 squared is +4 times 2 is +8. -1 squared is +1 times 2 is +2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. And 2 squared is 4 times 2 is 8. -2, 8. -1, 2. 0, 0. 1, 2. And 2, 8. Okay. So the point at 1 doubled to 2. The point at 2, which is 4, doubled to 8. The point at 3, which is 9, will double to 18. And overall, this makes our graph narrower as it has to stretch farther up. So it's a little bit sharper, steeper, narrower. So the larger the coefficient of x, the narrower the parabola will be. Alright, now to y equals 1/2 x squared. Let's draw in the parent function, y equals x squared first. Now let's make our table of values. We did calculate these earlier, but let's just plug them in. -3 squared is +9 times 1/2 is 9/2, or 4.5. -2 squared is +4 divided by 2 is 2. -1 squared is 1 times 1/2 is 1/2. 0 squared is 0 times 1/2 is 0, and it's going to mirror on the other side for this quadratic function. It doesn't always mirror over 0, but on the kind we've done so far it does. Now we graph the points -3, 4.5, -2, 2, -1, 1/2, 0, 0, and all the points where they reflect. And we'll draw in our curve. Hey, forget this little part. I drew the dot in the wrong spot. You can see that our new quadratic function is actually wider because each point dropped to half its height. So, the closer to 0 the coefficient of x squared is, the wider the parabola. And actually up here it should say, the larger the coefficient of x squared. So, x squared is the parent function, which has a coefficient of 1. And as the coefficients go higher than 1, it starts to get narrower and narrower. And as the coefficients drop from 1, it gets wider and wider until it hits 0, and that would be completely flat. The problem with that is then you wouldn't have an x squared term anymore, and it wouldn't be a quadratic function.